kind of on a little bit of a fast track, but I think that they can answer all of the questions that you could possibly have in the time that we've allotted. As Dr. Kaminsky promised you on April 26th, we've got some folks here to discuss the GPS options for retrofit of our passenger carrying aircraft. As I said, it's going to be brief. We'll be in here about 20 minutes. Colonel Mike Daggett, who led our Air Force Tiger team that identified the plan to retrofit our aircraft, is here today to talk to you. Colonel Daggett.
Good afternoon. I'm Colonel Mike Daggett. I led the Air Force Black Box Tiger team, and our tasking was to go out and provide a plan to install GPS, flight data recorders, cockpit voice recorders on all Air Force passenger carrying aircraft as soon as possible. And we were also tasked by Dr. Perry to develop an implementation plan to include the cost, schedule, and priority. What we came up with was we found that adjusting the final integration plan for GPS and Air Force aircraft was very difficult and very expensive. So what we did, we looked in how could we get this capability into our air crew's hands as quickly as possible. And that's where we came up with the GPS as soon as possible options. There's actually 4 options that we considered, and we have all 4 of them here today. The first was a commercial handheld GPS receiver. The second was the military plugger, the precision lightweight GPS receiver as a handheld. The third option was the handheld with a bearing pointer display. And the fourth was a handheld option with a moving map on a laptop computer, which we'll be demonstrating here shortly. Can we get that to come up, please, Jake? Okay, I brought along with me Major Jake Thorne, who will be demonstrating the moving map display, along with Captain John Phillips from our GPS Joint Program Office, and Major Ted Steele, who is an Air Force navigator who has extensive operational experience using these capabilities. We proposed funding approximately 737 of these systems, various combinations of these systems for a cost of approximately $4 million. Total? Yes, sir. And with that, I'd be glad to take any questions.
I'm sorry, you said 737 of the systems, right?
Systems, various combinations of the systems. What we will do is leave it up to the operators in the field to determine what is most appropriate for their aircraft. As we went through these, we looked at them. One of the bases that we said was we did not want to overburden the aircrew. And obviously in a C-21 with a very cramped cockpit, with only 2 crew members, a moving map display with a large laptop computer may not be the appropriate solution. So we'll turn to the operators out in the field to determine which of these options that they prefer.
What have you learned so far? Which options are being selected more than?
It runs the gamut, sir. Where we have multi-crew members, where there's navigators on board, the solution was the moving map display. The smaller cockpits is the handheld. And again, we have not got all the requirements down, but primarily the handheld. Sir.
Colonel, 2 questions not related, in a sense not related. First of all, this is interim, right? I mean, eventually you're going to have something mounted on the aircraft.
Yes, sir.
Okay. And secondly, in your opinion, wearing command pilot wings, if the aircraft commander of the ill-fated Ron Brown plane had one of these things in the cockpit, would that have told him that he was straying off the center line?
I really can't answer that, sir. That's under investigation now. I do not know.
I don't mean him. I'm saying if you were flying in a comparable aircraft using the kind of beacon that he was homing in on in bad weather, but you had one of these sets, would this tell you if you were 3 or 4 miles off course?
The resolution on this, again, with the plugger, I get a 16-meter accuracy. With the commercial variant, 100-meter accuracy. With the resolution capable on the maps, that I would be able to detect a deviation from a planned course.
Sir, we're going to show you in the demo
Yes.
how it works, and you can detect deviations.
Okay, worldwide, regardless of weather, right? Okay, thanks.
As long as the map support, the DMA map support is available, I can pull up anywhere that I wish to navigate, put in a planned course, and detect deviations.
Well, a 100-meter, I'm sorry, a 100-meter variant doesn't sound very precise if you're in fog, rain, and sleet, and you're trying to hit the end of a runway. I mean, I realize that's a
Yes, sir.
layperson's question, but 100 meters isn't very accurate, is it?
That's 300 feet will position you within 300 feet of where you
But I
want
mean,
to
if
be.
you're 150 feet to either side of a runway, what you gonna?
Yes, sir.
That's within the
This-
requirements of TERPS though, sir, under
Yeah.
FAA. 300 feet is still well within the safety margin laterally.
I see.
You still have to be above minimums.
Sure,
Yeah.
yeah. This
Now,
is
one-
not an aid at shooting the
Yes.
approach down to minimums. This is a situational awareness where I am geographically.
That's one of the things that we need to make clear. We are not proposing this as a navigation aid in the National Airspace System. We're using it as a navigation aid to shoot approaches with. This is solely a safety system, a situational awareness system that the pilot can maintain his orientation around significant terrain. Now, obviously, the more primitive conditions you're flying in, the more valuable this can be. Obviously, if I'm flying in ILS into JFK, the utility may be less than would I were flying in a strange airport with significant terrain along the final approach course.
What's your acquisition strategy on this? Will these things be competitively procured, or are you sole sourcing these things?
I do not know. I will have to get the answer to that question if we could take that.
On the laptop, how often does the map update with position?
It's once a second.
Without the plotter and the map, you just had one of, let's say, the plugger in the cockpit. You would need to look at the coordinates, the latitude and longitude, and then plot that on a separate map.
No, it also will give me between two waypoints that I've established. I can select a cross track on it, and it will tell me between those two waypoints whether I'm left or right of course and how far.
It'll
So,
give you a deviation. It won't give you a graphical display, but it'll
No.
tell you you're off course.
So somewhat like a DME, except we'll give you left and right rather than to and from, right?
yes.
As well as to and from. As well.
Another question, the commercial thing primarily, is it applicable to ground transport? Say you're driving across the outback and you can put one of these in your car and you get your coordinates right.
It's been demonstrated in a bus also that it can track. I don't believe we have it here, but we actually, the resolution, we can did an approach into Andrews, did the GPS trace, and could see the airplane landing on the runway and then taxiing off at high
We'll show you the
speed.
capability, sir. It has capability of maps and also satellite imagery. If you have a photo of an area,
It's
it'll provide a
commercial,
photo.
right?
No, sir, this is all DMA data that's owned by the government right now, that's in this system we're going to show you.
But I mean, you talked about a commercial one being the first option.
The GPS would be commercial, the driver of the system, no doubt, but
Well, we're
to
talking-
have the technique that you're talking about as far as the maps and imagery, you'll have to have some kind of display
okay.
system.
When we're talking about the commercial, this is a GPS commercial receiver here. Excuse me?
What is the schedule to install these?
As soon as possible, we are looking to have it, the aircrews trained, the guidance published, and the equipment in the field by 30 September.
All 737?
Yes, sir.
How many aircraft is that?
The aircraft varies. We're looking at the procurement strategy, whether we're going to buy them one per aircraft or if we're going to buy a set where they'd be issued to the crew as they check out of base ops, much like we do with our pub skits that we fly with. So we haven't determined the total number that we're going to buy yet.
How many planes are there in the fleet that we could potentially use?
Let me. Can we get back to you on that? I don't have that right at my.
I'm confused. When you talk about the commercial GPS receiver now, that's available to anybody who wants to go into a Radio Shack or somewhere else and purchase this, correct?
Yes, sir.
Okay. You have any idea what the approximate cost is?
How much did this
Low
particular
end,
receiver?
The little one we refer to as the hockey puck's $299.
Okay, but I could put that in my car, for instance, driving cross country, give me coordinates, correct?
It'll give you coordinates, and also you could put a laptop in your car and have a moving map. That's-
What's the high handle?
moving map?
If 299 is the low end, what's the high end?
The high end, you can get up into thousands of dollars depending on the complexity of the system and what you need the system for. If you're talking a fully integrated GPS system in an aircraft, we're talking much more expensive. This, again, is not an integrated solution. It's a standalone.
But the high end might include maps within it, as opposed to having it overlaid in a computer, to have to draw on a computer for maps. Is that what you mean? Is that why it costs more?
Yes, sir. Put on a radar scope, like much of the data out of a flight management system is now presented to the pilots in an integrated system. Yes, sir.
Do you know the manufacturers of these models here?
Of this equipment, the plugger is Rockwell. This commercial, again, is a Trimble. There are many manufacturers out there. As far as the antenna, Micropulse, this is a sextant port antenna. Many of the Air Force aircraft have a sextant port, and this is designed to fit through there. The computer is a generic IBM compatible computer, and the software that drives this is DMA.
How much coverage does that give you? Worldwide.
Got worldwide coverage of maps on about 125 CD-ROMs, and that covers elevation data and various maps.
Here, when we get to the demo, I'll show you the capability. And that capability I show you, we have data worldwide already in the government.
It won't give you altitude though, will it?
Yes. It'll give you elevation.
Elevation.
Of course, altitude is whatever your airplane is flying at on your altimeters, but it will give you the elevation of the terrain you're flying over.
Do you mean with the GPS give elevation?
Yes.
Yes, it also feeds MSL.
Would any of these be capable of being compatible with the Russian GLONASS system?
No, sir. This is all designed for GPS. Again, GLONASS has a totally different signal structure than GPS.
But there are some units that will take either one. None of these will do it.
I do not know that. Earlier, there was some GPS GLONASS development of a common receiver to accept both a GPS and a GLONASS signal and come up with a position solution, but I do not know the status of that anymore. Yes, ma'am.
You mentioned the kits that some units have that they can take onto an aircraft.
Yes.
Do you know if there are any requirements to carry those kits under certain conditions at certain airfields?
No, none that I know of.
Would you like to do the demo for them?
Yes, let's go ahead. What we'd like to do now is show you the demo. This is an actual demo from an aircraft track that was done yesterday, and show you the different capabilities.
Basically, the software I'm going to be demonstrating to you is the mission planning software that we have out in the field today in the Air Force with the F-16s and other active duty units. It's a Windows-based system. It has both flight planning. What I mean by flight planning is you can go in and build your route of flight using the airways, nav aids, etc., and plot out your course, do your fuel times and computations. Then the window I have up right now is a window of maps. It uses standard DMA data, any scale map, all the way down to satellite imagery or DTED, which I'll be showing you. What I have up here for you is also the GPS plot. You bring the GPS online, you activate it, and it stays there in the mode, feeding data to the computer all the time. It's hands off. The aircrew doesn't have to do anything once you turn it on. As you scroll across and fly the course, it plots where your airplane is going. I intentionally put a route in here that deviated so that you can see that if I was planning to fly this route and I deviate, I'm going to know it fairly quickly. The little red trail shows where I've been. The little airplane shows where I'm going at that instant. Underlay any map under it that you want to. The other capabilities that we have integrated into this system is I can change my flight plan as I'm going along. If I have to deviate because of weather, etc., I can do the flight planning real time while it's tracking me, plot my new course, and move right onto that new course. The capabilities as far as the imagery, etc., I'm not going to take in. This is obviously coming yesterday from Memphis, headed to Washington, D.C. I'm going to take you out to the Montana area now where we have, obviously, terrain. And I'll show you the capabilities of what all you can underlay with these overlays. Basically, this route of flight says we're going to take off from Minneapolis and we're going to go to Jackson Hole, Wyoming. We can zoom out to a big global picture. All of this can be done, by the way, anytime you want to with the mouse as you're flying along the cockpit. As we said, if we have a cockpit that allows for a navigator, he would be the one operating this. If it's a two-place airplane, this can sit on the console next to the co-pilot. As you can see, even from this terrain, you start seeing, just with the satellite imagery we had there, the Landsat, that it's a fairly aggressive terrain. Now we just move down into the scale of navigation maps, and the aircrew can choose what scale he wants. All the data comes from DMA on these CDs. This is already published by DMA and produced worldwide. It comes to the aircrews into the squadron on a 26-day basis for accuracy. Some of it does, some of it longer. It depends on the cycle of the schedule.
Are those available to civilians?
No, sir. DOD. The type of things he can do, and I'm going to be showing you all scale of maps. We also can go down to satellite imagery and, more importantly, DTED. DTED is digital terrain data, and we have it in 3 arc seconds. But what it means is we know the elevation post. Through some software, we can make it look 3D so that you can see the mountains, the valleys, etc. That's what I'm going to show you. This is going into Jackson Hole, Wyoming. You can choose to have this up on the display. Go down one more. And this is the runway right here. You can also bring up satellite imagery, which I'll show you in just a second. I don't have satellite for Jackson Hole, Wyoming. I'm going to show you Eglin Air Force Base, but you'll get the concept. You could also switch to one more that in a VFR conditions, you could actually use that shows you the runways, highways, etc. It's a satellite imagery. But this is digital terrain data overlaid to look 3D. So as I come down and shoot the missed approach, I certainly can figure out where I don't want to go. It's not a navigation aid. It's a situational awareness tool. If I start the approach, if nothing else, I look down at the console as I start the approach and say, well, I know I don't want to go to the west. I don't want to deviate west. As you asked earlier, if you put the approach course in and it plots out, and as a little airplane comes down here, you'll certainly see if you're deviating. But once again, I want to stress it's a situational awareness tool. It's not a certified FAA instrument approach procedure by any means. But it is a great tool for the aviator as just another piece of information while he's doing his job.
We refer to it as a peek out the window. It's not certifiable necessarily, but just looking for a moment at this kind of a display instantly situates you in the conditions in which you're flying.
Somebody has to look at it.
That somebody has to look at.
Yes, you do have to look at it to gather that situational awareness, but it's all hands off. As you're flying along, this thing scrolls automatically. You don't have to do anything to it. As the GPS tracks you from Minneapolis to here, the maps scroll with you. Does auto updates. You can have this oriented to aircraft heading or true north, depending on how you fly your airplane, and that varies amongst the airplanes out there as to what orientation you're trained to look at.
How accurate is that topographical display?
It's the lat longs and the GPS and stuff we spoke to. These are down to pixel dots. It's as accurate as the underlying data from DMA, and for each map there's a specification that says this data is good to within X number of feet. Once again, we would not attempt to fly into Jackson Hole, Wyoming on this screen, but it certainly, as I said, with TERPS data, etc., it gives us the ballpark safety margin that.
Well, worst case scenario, you could. I mean, if you lost everything and the weather was bad and you had an emergency, you could.
That would be the aircraft commander's decision, sir, at that point, obviously.
Well, if you had no decision, you're going to come down. Either that or a nylon approach. What I'm saying is, worst case, you could actually use that to stay clear.
If you had no other options, but if certainly this is not the goal of the program we're working on, is to get this approved as that. Certainly pilots do whatever they have to do when emergency situation.
Isn't there a certain amount of variability in the GPS data that, depending on satellite locations and those factors, that some systems actually have you have a correction factor put in, for example, for
You might want to show them the window too.
Yeah, let me pop that up.
Kevin Phillips is from the program office.
I'd be happy to address that question.
While you're answering it, I'll bring the other thing.
Okay, what you're talking about is selective availability. The DoD intentionally degrades the CA code so that there's less than military capability, which is on the order of 16 meters. If you wanted that level of accuracy, and that's certainly what you're going to need to do approaches someday, you're going to need to be able to differentially correct that intentional signal degradation.
Do you see a day when you're going to link up GPS with an ILS and/or GCA or something comparable?
Absolutely, we're working on doing that today, and that's part of the full-up GPS integration that we're looking to accelerate right now.
But the plugger has a chip in it that brings it down to 16 meters, isn't it?
That's right. This system here is accurate on the order of 16 meters reliably when you have what we call the P codes loaded up.
How many feet is that for?
16 meters, 48 feet.
As I said, here's the image of satellite imagery. That's the additional one I didn't show you yet. Maps, digital terrain, and satellite imagery can be projected and flown over using this system. To go back to the question about how does the aircrew know what's going on with this, I'm going to pop back out now and show you that GPS plot. I might add that all of this software that we're showing you here is currently in the field, owned by the United States Air Force, used for mission planning. So it wouldn't be a purchase of the software. What we were talking about that the team is looking into is the hardware that we would place this on in the airplanes.
That was the $4 million figure you gave us.
I believe so, sir.
Is the software available to all units or just for fighters and others that have the NSS system?
To all units. We currently distribute this software out of Hill Air Force Base to over 4,000 users.
Excuse me, you said this would be, by 30 September, these would be loaded down. Somebody asked you how many planes, and you didn't, you said you didn't know, so it will not be
No, we
730.
said we'll get you that figure. We have it. He just didn't want to have to spend time calling through it.
My
There's a
question
difference
was, you're
between-
talking about 737 systems, are you talking about several systems, perhaps on one plane, or 737 planes?
No, what it is there's already some equipment already in the field. What we looked at is those airplanes, those passenger carrying aircraft, again, limited into passenger carrying aircraft, was that when we went out to the MAGCOMs and said, how many of these systems do you need? We came up with 737. And it broke down into various different options that they considered.
Point is, it seems like these ones per plane.
Yeah.
I don't understand.
Well,
We're talking
again-
about 737 planes by September 30th.
No, because again, we looked at not one per airplane, but buying, for instance, 20 per unit, so that when a crew goes to base operations, he checks out the system, takes it to the airplane with him, rather than having this installed in the aircraft.
This whole system that we're looking at proposing fits in a normal flight bag. So you just walk with it to the airplane you're going to operate
So
with.
737 of these could service many more than 737 planes.
Yes.
depending-
Yes. Because not all aircraft are flying at the same time. Some are down for maintenance, some are at home station flying local missions where the equipment isn't needed. So what we looked at was rather than one per aircraft was the concept of giving so many, because what the crew is going to need to do is come do their mission planning prior to the mission itself.
But again, you plan to have 737 of these systems in operation in the field by September 30th.
The actual number will be higher because there are already some systems in the field now. For instance, we have several units that have gone out and procured these systems on their own and have been working with them over the past few years, developing how they're going to use it, mainly in a tactical role.
Are air crews mandated to use these, or is it their choice?
That again, we're still developing the guidance on the use of this equipment. It's a capability that we're going to put in the aircrew's hands. I really cannot answer that at this time.
You said these are carried on and off for each flight, therefore they are not installed in the aircraft?
No, these will not be permanently installed in the aircraft. Again, this is an interim solution, and one of the keys to success is that the crew has to have the equipment available. Like we said, he can do his mission planning on this prior to.
It has more utility than just the moving map display. There's 2 in each F-16 squadron in the world today without the GPS. Obviously, in an F-16, there's not room for a laptop. But what they use it for is to do all of their mission planning, target study, etc., load all that data onto a cartridge they take out to the airplane. We're taking it one concept step further, though, for the multi-placed airplanes, passenger type. You can actually take this into the airplane and have moving map. So I didn't neglect you to answer your question. I can also bring up a little window that gives me the GPS data. as far as the lat longs, the number of satellites locked up, all that information. So everything is presented to the air crew, how he chooses to use it to monitor the system.
Would you say, and I think I know the answer already, would you say that it's really almost inconceivable that air crews would not use this, I mean, even if it's just for a check and balance?
That's correct. It's almost addictive. As soon as you get used to this kind of information being available to you, it is like flying in a blacked out cockpit to not have it to look at as you're flying along. And it becomes a routine part of the cross checks just for a feeling of where you are. It's like using your inner ear. You sense where you are through the use of this kind of a system.
Has the buy of the 737 begun yet?
No, it has not. We are still looking at different acquisition strategies. We have to go out and procure the software. We're still getting the final requirements from the MAGCOMs. Again, that 737 figure was what the Tiger team came up with at the time by going out and polling the different users who operate these aircraft. And now what we want to go out and provide greater fidelity to that number. So that number can shift a little bit. And if a user changes his mind, it may be that we had planned on buying 500 laptops that now we'll only go out and buy 450 because he's changed his mind. He wants a handheld.
Do you have an estimate on when it might begin?
John, have we? End of May.
Is there a priority for installation? Will the squadron at Andrews get them first, or do they have them already, or are we talking about just going where they're needed?
The unit at Andrews, the 89th, already has some of this capability on board, but no, we have not established a priority per se.
Is this Air Force dollars or is this DoD dollars? I forget. I mean, is this Air Force specific dollars that will be buying this equipment?
Air Force dollars.
Okay.
Have you found the offsets yet?
That I can't speak to.
What is again, a question from the grid on Washington. What is if you're flying around in clouds now, you're landing in rain and fog and you can't see anything, what does a pilot use now besides looking out the window?
Well, we use
Telling
instruments.
accurately where he is.
Well, we have the ILS system, which
We have precision approach systems that we use. ILS, VORs, NDBs, TACANs. It varies, and of course, one of the discussions was it varies with the age of the aircraft we're flying, what equipment it's equipped with.
Or the ground equipment.
Or the ground equipment also. That's right, sir.
It depends on the airport you're going into. For instance, if I'm landing at JFK, I have a Category 2 ILS. The airplane I flew was Category 2 certified, so I could go down to 100 feet and a quarter of a mile visibility. Currently, you know, there are Cat 3 approaches out there now. And
Just as an example, the question that's been raised, of course, is the difference between the equipment might have been on in Dubrovnik as opposed to flying into Sarajevo where the military is concentrated. There might have been better equipment.
Sure.
Sarajevo.
You know, the equipment varies around the world as far as the ground-based equipment that's available. Certainly, most countries don't have the type of approaches and capabilities we have at most of our major airports in the United States.
One thing you might want to mention with a Bendix approach coupler, for instance, the technology exists to fly an ILS right into the ground. I mean, flare out and land the aircraft, hands off.
Yeah, so that was the one he was referring to as Cat 3.
the C-141, an old aircraft, had an auto-land capability, Cat 2, where the airplane would.
But you have to have the
would
right
land itself.
ground.
You need the ground
systems to
equipment,
utilize
the crew training. Yes, sir.
What do you estimate it will cost to do the longer-term solution of having these integrated into the cockpit?
The figure we briefed, GPS, I don't have the broken out GPS figures by themselves, but we were looking at $264 million. Was briefed for the flight data recorder, cockpit voice recorder, and the accelerated GPS program, along with the interim GPS program.
Accelerated GPS program is what?
That was to Dr. Perry's direction was to get GPS on board as soon as possible. So we did go in and look at accelerating the GPS program, and found that we could accelerate it a bit by getting it on quicker, by doing more installs per year. We couldn't move that schedule to the left very much. Excuse me?
How much would it cost to accelerate?
I do not recall the GPS specifically. I will need to get back to you on that.
Is that 264 then, the accelerated GPS plus the black boxes? Is that what
Yes,
we're
sir.
saying?
Okay, excuse me, that's,
Yeah.
we're gonna have to break down the
Apologize.
equipment while they're doing that.
Thank you very much.
Yes, sir.
Well, we got you, is there any update on the B2, any,
No, we posted that.
Here, so we don't want to forget.